Hello viewers, welcome to this season of external examinations. As you all know, WASSCE exams are ongoing. I'm not saying that to scare you, I'm only here to help. Yes, we'll have a likely chemistry question, a theory question at that. And it goes thus. A sample of carbon is burnt at a rate of 0.50 grams per second for 30 minutes to generate heat. 1. Write a balance equation for the reaction. 2. Determine the 1. Volume of carbon 4 oxide produced at STP. 2. Moles of oxygen used up in the process. Given that the relative atomic mass of carbon is 12, oxygen is 16, and the molar volume of gas at STP Vm is 22.4 dm cube. Yes, when you see a question like this, I will tell you to just calm your nerves and understand one thing. Carbon is burning in oxygen to produce something. Though the raw question here didn't really say, is the burning complete or incomplete? But one of the sub-questions here gave us a clue, and that sub-question is, he said, volume of carbon 4 oxide produced. So that indeed tells us that the product is what? Carbon 4 oxide gas. So to answer the first question, let's go. Here we are. We're asked to write a balance equation. So we have carbon, which is solid, reacting with oxygen, which is a gas, to give us carbon 4 oxide gas. So you do atom count. Carbon is 1 here, oxygen is 2 there. So the equation is balanced. Failure to write a balance equation, this question should originally have 2 marks. You just get 1, okay? Then the second question, which is determining the volume of carbon 4 oxide gas produced at STP. All right, I must tell us at first that this is a question that has to do with calculations involving chemical equation. Just that we're not given the direct mass of carbon that burnt. They only gave us the rate at which it is burning and the time. And I believe with this, we can get the mass of carbon that actually burnt in this 30 minutes time. So to do this, from the unit, here, the unit 0.50 grams per second, you will indeed know that rate here, the default formula for rate here is mass divided by time, because when they said per second, that is per unit time. 0.50 is mass because it is in grams. So with this, we can now get the mass of carbon. So if we make mass the subject here, mass would be rate, let me call it R, times time, which is T. So that will leave us with the rate, which is 0.50 times the time, 30 minutes. Because the rate is in per second, grams per second, so we need to convert the time to SI unit by multiplying with 60. So that will leave us with 0.50 times 30 times 60. We'll be left out with 900 grams. This is the mass of carbon that actually burnt in this time and at the rate that was stated in the question. Okay? Then, to respond to the first sub-question here, they said the volume of CO2. Now, in responding to stoichiometry or calculations involving chemical equations, what do? There are 2 sides of it. One is the data you get from the balanced chemical equation. That is 1. 2 is the data from the question, and after which you compare the 2, use simple direct proportion method to get in your answer. No big deal about this, I promise you. So let's go. From the equation above, okay, forgive me, I'm using the short form of writing equation. We'll have it that 1 mole of carbon burnt to give us 1 mole of carbon 4 oxide gas. Okay, I don't want to speak too much grammar here because that won't really give us any extra score. Just make it simple and concise. Okay, and from here, 1 mole of carbon in grams is equivalent to what? 12 grams. So this means that, this implies that 12 grams of carbon burnt to give us 1 mole of any gas, including CO2, carbon dioxide gas, is 22.4 dm cube. So this would mean 22.4 dm cube of CO2. So from the chemical equation, from the balanced chemical equation, 12 grams of carbon burnt to give us 22.4 dm cube of what? Carbon dioxide gas. Then from the question, where we got the 900 grams of carbon got burnt. So 900 of carbon would burn to give us an unknown volume of carbon dioxide gas. I guess this is straight to the point and clear. All right, at this point that we've got the data from the equation and the data from the question, we'll simply cross multiply, okay, and make x the subject of the formula. So if we cross multiply and make x the subject, without wasting much time, it would be x equals 900 times 22.4 divided by what goes with x, which is 12. Okay, if we do this, we would have 900 times 22.4 divided by 12. It will leave us with 1,680 dm cube of carbon dioxide gas. This indeed is the volume of carbon dioxide that was produced when 900 grams of carbon got burnt, based on what we got from the question. I believe this is very clear and easy to really understand. Now let's go to the second sub number, which is sub number 2 of number 2, and it goes moles of oxygen used up in the process. So we're still going to make reference to the chemical equation. I may rewrite it so that we'll see it again. So we have carbon solid reacting with oxygen gas to form carbon dioxide gas. All right, here they say moles of oxygen used up. So here we can compare carbon and oxygen, or oxygen and carbon dioxide gas. Anyone will compare would give us the same answer. So let's go. Here we have 1 mole of carbon reacting with 1 mole of oxygen from the balanced chemical equation. Okay, all right, realizing from the balanced chemical equation once again that 1 mole of carbon burns in 1 mole of oxygen. So 1 mole of carbon here, remember, is equivalent to 12 grams of carbon. Burning 1 mole of oxygen here is what it gives us. Remember, this is the data from the balanced chemical equation. Okay, and if this is the case, then what if from the question again, 900 grams of carbon when it's burnt, okay, still leaves us with what? An unknown, x. I love using x, forgive me. Okay, then if we cross multiply and make x the subject once again, we'll have x equals 900 times 1 divided by 12. Yes, I said times 1 for the sake of substitution in your responding to your question. If this 1 is not there, I'm sorry, a wicked marker will deny you of getting that mark for substitution. Yes, I said so. Then when we do this, 900 by 12, let's see what it leaves us with. Leaves us with 75 moles. 75 moles of oxygen is used up when 900 grams of carbon got burnt. Thank you for watching. Remember to like, share, and also subscribe to our channel. Thank you so much.